Hi everyone, so today we'll be talking about logarithmic and exponential laws. The first law we'll go over is the product law for logarithms. If we have the expression log base b of x times y, where the product, hence the name of the law, product law, is inside the parentheses of the logarithm. This can be rewritten or expanded by writing log base b of x plus log base b of y. If it's not clear why this is occurring, let's take a look at the exponential version of the same law. So if we have a base a to the power of x multiplied by that same base a to the power of y, so it could be a different number or the same one, then this is equal to a to the power of x plus y. So what's happening here is that a direct application of the fact that the inverse of any logarithmic function is an exponential function. In this case, we can see this because here we start off with two exponents, and this is simplified to just one exponent. Inversely, we start with one logarithmic expression here, and then we end up expanding it into the sum of two logarithmic expressions, which makes it easier for us to calculate. Assuming we know the value of b, we can just plug it into our calculators. Alright, so now let's move on to the quotient law. So the quotient law is very similar to the product law. The only difference is in the parentheses of the logarithm expression, we are dealing with division. So let's say we have log base b of x divided by y. How can this be expanded upon? So we can rewrite this as log base b of x, and so this time instead of adding log base b of y, what we're going to do is subtract, because we're doing division this time. And just like in the previous example, there's an equivalent version of the quotient law for exponents. So a to the power of x divided by a to the power of y. If we use the same logic here, this should be equal to a to the power of x minus y. Now let's go to the power function. This is the most important one and will appear many times throughout your future mathematics courses. So this can be written as log base b, but this time in the parentheses. This is the only part that changes. What's in the parentheses is x to the power of y. So what we do here is we take, this is the law. When we have a power inside the parentheses, what we do is pull it down and make it the coefficient of the logarithm itself. So now this is equal to y log base b of x. There you go. The exponent version of this same law is b to the power of x, and then all of that to the power of y is just equal to b to the power of x times y. And we can see why this works through an example. So if we have like b squared to the power of 3, how would we normally calculate this? We would take b squared, multiply it by itself a second time, but that's only b squared squared. Then we do it a third time, and that would give us b squared times b squared times b squared. And how do we get our final answer? We use the product rule. Same thing here. The product rule. And so, but instead of just having x plus y, now we have a third variable. But the same technique can be used. So now we just do b to the power of 2 plus 2 plus 2. And the final answer is b to the 6th. What is another way to get this much quicker? All we have to do is multiply 2 by 3. So b to the power of 2 times 3 is equal to 6. Alright, so now that we covered all the logarithm laws and exponent laws, let's do a couple exercises to really get the hang of it. So let's say we have this example. Let's say we have log base 5 of 25x. Now your task is to expand this expression. So how would you do that? Think about which law we can use to expand this. What we can do here is we can expand it by saying log base 5 of 25 times x. So since we have times here, we can use the product rule. So log base 5 of 25 plus, we're doing plus because this is the product rule, not the quotient rule. So we do log base 5 of 25 plus log base 5 of x. Now, how can you simplify log base 5 of 25? You can plug this into your calculator, or a simple way of doing it is just 5 to the power of what is equal to 25. In this case, it's pretty straightforward. You know it's 2. So this is 2 plus log base 5 of x. There you go, and that is your final answer. If we have the expression log of x cubed divided by 100, how can you rewrite this in an equivalent form? So since we have division, we're using the quotient rule this time. So we do log of x cubed minus log of 100. Alright. Then here we use the power rule. Pull down the, so think of this as in parentheses, so x cubed. We pull down the 3, and we get 3 log x. 3 log x minus, so what is the invisible base under any log when it isn't specified? It's base 10. So in this case, log base 10 of 100 is, as we did over here, we can do something similar. 10 to the power of x is equal to 100. So what is x? In this case, it is 2. So the final answer is 3 log x minus 2. Okay, so in this question, try to find this question is asking us to find the equivalent expression once again. Except, of course, the expression within the parentheses looks a little bit more complicated this time, but really we're using the same techniques. Just to remember, what is the first thing we need to look at? We need to look at, is this a power rule, product rule, or a quotient rule problem? So we have division here, so we immediately know this is a quotient rule problem. So we can already start off by doing this. Log base 2 of radical x minus log base 2 of y to the power of 5. This is then equal to log base 2 of x to the power of 1 over 2 minus log base 2 of y to the 5th. At this point, there's another rule that we should be using to further simplify this. So we can pull down the 1/2 here, and we can pull down the 5 here. So it turns into the coefficient for the logarithm. So now this is 1/2 log base 2 of x minus 5 log base 2 of y. If this video gave you some clarity on today's topic, feel free to leave a like on the video and consider subscribing to the channel. Until next time, I'll see you later.